Hey, hi everyone. Welcome to yet another video by Product Managed. This one is in continuation of the first part where we learned about Amazon AWS cloud concepts. So if you remember, I think we did cover ECS in that first part, and had also discussed about the use cases, and then we had covered Lambda, right? So now, basically, coming to this part, right? So essentially, I think here we are going to look at another couple of important services that are provided by AWS. One is called the Fargate, and we are also going to look at the load balancer. Uh, so Fargate, I think quickly, right? I mean, what is it? It's a cloud computing service, basically, that is offered by AWS, and it allows users to run containerized applications without the need to manage the underlying infrastructure. Users can basically then focus on developing and deploying their applications instead of wasting time in provisioning and management of, like, the computer infra, right? So that's the biggest like, I would say, reason why this feature basically exists. Now, some of the key features for Amazon Fargate, right, are that it allows for containerizations. You can obviously package your application, correct? And what it also allows is, you can obviously bundle every aspect of the application, including its dependencies, right? So which obviously allows you to manage and across different environments. The deployment and management across environments becomes easy. It is serverless, which means that you don't have to worry about the managing part of the server infra, right? AWS will carry the load on that side, and obviously the scaling up and down will be managed, as and when it is needed, right? So it's basically servers on demand, if I have to put it that way, right? High availability, right? Because instance replacement, for example, you can quickly deploy that. You don't have to worry about it. AWS, obviously, the backend services will take care of it, right? The security, I think, right? Network isolation, encryption, right? Identity access, that is there. Integration with other AWS service, right? So this is where the ecosystem play comes into picture, right? So where Fargate can be integrated with other AWS services like container registry, right? Obviously, you saw, like, I think, container services, right? And AWS Lambda also, correct? It is obviously cost effective, because it's the way to look at cost effectiveness is that you are not putting developers to manage the infra. So that way, it's definitely cost effective, but you also have to keep an eye on your bills, right? So it shouldn't happen that you, over a period of time, the developers that you hadn't put in, AWS is basically, because it's managing the resources and scaling up or down, there's going to be a cost associated with it, right? So it shouldn't happen that you end up paying more, versus where if you had kept the developers, you were better off. So I think that part probably more subjective, based on the size of the team and the application itself. Support for multiple container runtimes, you can obviously include a lot of containers, Docker, RKT, and others. Multiple programming languages goes without saying, Python, Node.js, Ruby, Java. Real-time monitoring and logging, I think this is by far the most important aspect that I have to say for Fargate, which allows you, I think, for real-time monitoring and logging, right? So essentially, I think when you're deploying web applications, right, to the container service, you should also focus equally on cases where I think your web application is not going to perform as expected. So there should be a limited period of time where the log services or logging capabilities are there that allow your teams to basically do the troubleshooting, which is where I think most of the customer issues will come into picture. Your customers will complain, for example, for whatever reason, right? Button not working on an application, flows not working according to their expectation, breaking down of, I think, code at some point, right? So this has to be captured somewhere in the log services, right? So I think this is where your developers will save a lot of time, but if it is integrated, right? So Fargate does provide that integration with CI/CD tools. I think, such as Jenkins and Travis CA. I think you can use, to automate the deployment pipeline. So that I think is the I would say the key benefits, right, of Amazon Fargate. Now, I think if you look at it and remember, I think when we were looking at the ECS console, in the infrastructure side, there was an option that you could go with Fargate, which is exactly what we had discussed. This is like pay as you go kind of a service, where you have zero maintenance overhead, no developer overhead, right? No infra teams. The cluster obviously, can take care of through the Fargate. You can scale up the cluster, scale down the cluster, correct? Instead of that, if you do an Amazon EC2 instance, right, then you have to do a manual configuration, right? And in that, you obviously have to kind of define a lot of parameters, like the scaling group that it is part of. Auto scaling is another functionality, right? I mean, you have to choose your architecture. You have to obviously choose the instance type on which you plan to run the workloads. Then I think the number of instances that you plan to launch in your cluster. So there's, I think, a lot of overhead maintenance, that I see. I think that is coming out of, if you were to go with manual instance, EC2 instances, right? So configurations will take away a lot of your time. And imagine, so for example, you were saying that the number of instances to launch in your cluster are five. Now imagine you're scaling up. Then those instances have to obviously also go up, right? So this is more like manual, not suited if you're deploying large scale applications. Might work for, I think, maybe if you're just starting out to build applications, you want to save on the cost, go for, I think, looking at the maximum instances, and then kind of create a peak of sorts, right, for your application instances. So that was, I think, it worked. But if you want, like, I think, scaling to happen as you grow and allow more users, I think this is probably like Fargate is a better choice. Now, coming to another important feature for AWS, which is the Elastic Load Balancer. Um, I think this is a service, again, integrated service that is provided by AWS. Obviously, you're using it to control the traffic, right? And traffic on what? Traffic on basically your Amazon Elastic Cloud Compute instances, EC2 instances, right? Uh, Obviously, it also helps you to improve the performance and scalability of the applications by routing traffic. So remember, we had covered what load balancers are, right? Uh, Load balancers obviously help to reduce the server response time, increase throughput, etc., etc. It's exactly the same load balancer capability that is now integrated in the cloud. What are the different kind of load balancers that AWS provides? Application, your classic, and target group load balancer. Each of these is obviously going to distribute traffic across multiple EC2 instances, which is the commonality. And then, depending on, I think, what load balancer you picked up, the layer, right? That is where it will be implemented. So, application basically is not going to look into the TCP traffic. It's only going to look at HTTP and HTTPS traffic, right? Where you can use, I think, some path-based routing algorithms and host-based routing, right? Uh, Classic load balancer obviously looks at all the three. HTTP is HTTP and TCP traffic, right? Which is to do with, I think, checking on session persistence from time to time, and obviously terminating your SSL. Now, I think the another important, like, I think, group load balancer is the target group load balancer, wherein I think your EC2 instances are defined as a part of a target group. Now, I don't know what could prompt you, but I can just give you an example. If you have an order management system, right, that could be your target group, right? And let's say at the peak of the season, right, you know that there's going to be a lot of incoming traffic, right? Maybe around Diwali and let's say any other festival. So if you define your EC2 instances in such a way that you know that the order management microservices that are running, for example, right, are to be like handled through a load balancer. So in that and then let's say the other ones, right, returns might also be high, but let's say returns are not high during that period, right? And let's say you have your product catalog scaling. It's also maybe not as high as just the order management, right? So which means that you can isolate those two microservices. Look at only this where your order management systems are hosted on those ECU instances, and then you basically scale those when the peak season arrives, right? So this is what I mean by target grouping, correct? And then of course, like it allows you for all the three HTTP, HTTP, HTTP path-based routing and load balancing algorithms, right? That you can use. Now, key feature, I think. Uh, don't go into I think all of the details, but let's just look at maybe a couple of those, the important ones. You can I think definitely go through the remaining, but I'm going to highlight the one auto scaling. I think by far the most important one because uh, as I mentioned, right, through peak season, I think maybe you have certain EC2 instances where it needs to uh, divert the, let's say, traffic based on the demand, right? So auto scaling up and down, I think both happen, and that is a very key feature. I'm a big fan of logs. I like applications to have the log management capability. So load balancers can access logs, right? So which is important because it tells you from where I think, let's say, the traffic is originating. If you were to, let's say, also build in some let's say monitoring of within, like, I think the log monitoring mechanism, I think that you will be able to do that because load balancer provided by AWS is able to access the log. uh, I think, okay, this is more like, I would say, health related, I think, aspects. Connection training and health checks, right? I mean, these are more related to, for example, a particular geography might be draining a lot of resources, right? So you need to obviously ensure that you're not routing any new traffic onto that. uh, Cross zone load balancing uh, is basically related to providing highly available infrastructure. Elastic IP addresses, range of IP addresses basically that you can define. Uh, and then you can obviously route the traffic from the internet, to the load balancer. So elastic IP addresses mean, like, from, let's say, a particular range to another range. You fix that range, but then as your, like, traffic changes based on the internet, let's say, applications that are running, you can divert it, I think, based on the range, which is like saying that you're providing more flexibility on your IP addresses, and load balancers can then easily uh, associate it with those IP addresses, for example, where there is, let's say, moderate traffic coming, right? So I think that's another aspect of his use cases of AWS load balancer. I think obviously they are essential components of many AWS architectures. They obviously ensure that applications are scalable, secure, and highly available, right? So if you are, let's say, building out web applications, right, can be then load balancers are going to distribute the traffic to web applications that are hosted on your EC2 instances, right? Pretty straightforward to understand. API gateways, right? So remember, API gateways are your interface between your application and everything else that follows, right? AWS load balancers can be used to distribute API gateways, right? Distribute traffic to the API gateways, which is basically sharing the responsibilities of, you know, ensuring that API gateways run smoothly. Correct. If you remember, I think API gateways also provide services like authentication, security, all of that, right? You don't want, like, basically your API gateways to be flooded with traffic, right? So this is another one of the uses. Microservices, yeah, traffic to microservices can be distributed. Again, they will be hosted on EC2 instances only. Understand that EC2 instance is your god. Everything is hosted in EC2 instance, right? AWS can also, I mean, load balancer can be databases also. We haven't touched, but I'm going to soon touch on this, the relational databases or Amazon DynamoDB. So any form of traffic to any of your individual system component can be managed by load balancer. So just let's say have a look at what are the different kind of load balancers. This is how the page looks like, right, for application load balancer, and essentially, sorry, the load balancer, and then you have different type of load balancers, right? You have application, you have network, you have gateway load balancer. Now, in each of these, basically, you can obviously go ahead and create certain configurations. So if you are doing, let's say, an application load balancer, right? Let me see if I can quickly. So here you see, for example, right, on this page, if you go ahead and log in, you'll see, I think, the create load balancer option, right? And I'm going to quickly come to this part, which is the create load balancer itself. Let me just quickly see. Yeah. So you see, I think this part right here. So essentially, here are your three types of load balancers, right? You have your application load balancer, network load balancer, and the gateway load balancer that we just discussed, right? So I'm going to quickly do a create, right? And just see, I think, what is actually present, right? So you see, I think there are a lot of basic configurations that are required, right? So just giving you a quick walkthrough of that. Load balancer name, right? That's fine. Whether it is internet facing, right? So this is the scheme basically. You can use it for all your internal, like, traffic as well. And you can use it from the traffic that is generated from the internet. The IP address type V4 versus V6, I think that is the distinction there. And I think the network mapping again, right? So the network mapping, I think, is basically used if you have a, let's say, a virtual private cloud, right? And obviously, the internal, I think, VPC, right? I mean, VPC, as the name suggests, is a private cloud. It's not a public cloud where obviously you can expose the endpoints. But this is a VPC, which is, that you have defined, and that you cannot change the configuration after the load balancer is created, right? So be careful about, I think, this step. And of course, like, I think mapping zones are there, which is essentially nothing but where I think your clusters are running, right? And I think one more important part is the security, I think, groups. So security groups, I think, set of basically firewall rules, right? That are used to control the traffic of your load balancer, right? And then the final part is, I think, all your listeners and the routing that is happening. Um, Listening, I think, checks for, I think, obviously the connection request, right? Using the port and the protocol. The rules, obviously, that you define for a particular register, right, determines how the load balancers request to its whatever target group that you have, right? So you can define multiple, obviously, here, right? And then you can obviously map it to one or more than one test groups, right? So I hope, I think, this session on the two services, right? We covered, I think, the load balancers in details. Also looked at the console on how you create them, and then, of course, the first part of this video, right? We looked at another important service, which I think not a lot of people actually, I would say, cover in details in their system design videos. But nonetheless, I think, Fargate is an important service that you need to be, you know, understood well, right? So until the next video, please do like and subscribe to this constant to this content on product managed, and I will see you in another video soon.